Hawaii is well known for its many geologic features which are primarily related to its active volcanoes. These include tall cinder cones, lava tubes, and calderas related to recent eruptions. The main airport on the Big Island is even built on a 200-year-old lava flow. However, there is one notable volcanic feature on the Big Island which few people are aware of. There is a beach with a deep green color which consists almost entirely of gemstones. This may sound too good to be true, but I have physically visited this green sand beach during my studies. It is green as it's primarily built from pulverized grains of the birthstone for August peridot. So, how did this unusual beach come to be? This video will discuss this geologic wonder and describe how it formed. The green sand beach is called Papakolea. It can be found near the very southernmost tip of the Big Island of Hawaii as it lies 2.5 miles to the northeast. First, some background information. Peridot is the name used to describe gem-grade varieties of the mineral olivine. Olivine is a beautiful green mineral which is abundant in the upper section of the Earth's mantle. This silicate mineral forms at depths of up to 410 kilometers or 255 miles. Volcanic activity in Hawaii is caused by a large hotspot in the mantle which has created a regular supply of magma to the island chain for several million years. Since this hotspot is located within the mantle, it occasionally brings with it to the surface minerals in this section of the planet's interior. Thus, lavas which erupt onto the surface in Hawaii frequently contain assorted olivine crystals. The olivine within this beach originated 49,000 years ago when an explosive eruption on the flank of Mauna Loa occurred. At the time, a volume of magma traveled upwards towards the surface. This caused nearby rock to be heated, which in turn began heating a section of seawater. Soon, some of this seawater flashed to steam, causing pressure to build. Then, the pressure became too great and the ground exploded upwards in what is termed a phreatic eruption. Pyroclastic flows subsequently raced across the landscape and water in every direction, traveling several kilometers. Large particles of material ejected by this explosion then fell back to the ground, forming a wide circular structure known as a tuff ring. This structure measured 250 meters long, 120 meters wide, and 38 meters tall. This ring contained numerous fragments of lava which contained the highly abundant olivine. It did not take long after the explosion for part of the ridge to collapse into the ocean due to its interaction with waves and wind. Erosion has also occurred throughout the rest of the tuff ring, creating finely grained particles of sand. Both the olivine and the surrounding basalt then fall to the shoreline. Since the olivine is denser and harder than the ash fragments, it settles close to its origin, while the lighter basalt fragments wash away into the ocean. Over many tens of thousands of years, this has created a beautiful beach filled with numerous peridot crystals. Accessing this site is done via a parking lot near the southern tip of the island from which a several-mile hike is required. I recommend a trip as it's fun to hold thousands of green peridot crystals in your hand. This beach is one of only 4 green sand beaches on the planet, meaning it is truly a unique feature. The other 3 are located in Guam, Norway, and the Galapagos Islands. Technically speaking, this sorting of material based on density could occur with any other mineral if it's abundant enough. This means that a golden pyrite beach is theoretically possible. I hope that you enjoyed this video. If you'd like to request a specific topic, please leave a comment below.